So today we're going to tackle one of the most commonly confused topics in chemistry, which is oxidation and reduction reactions. Now, it's very easy to confuse these two terms, and which is why I made a video so that we can finally understand the main difference. So to understand the difference, we have to know what an oxidation state is. And if you guys remember back in Chem 1, an oxidation state is an indicator of a hypothetical charge that an atom would have if all the bonds were completely ionic. So oxidation states and understanding how to find them is the only way to understand oxidation reduction reactions. So if you don't know what oxidation states are or how to calculate an oxidation state, then please revert back to your notes because that's very essential to understanding this topic. Now, oxidation is the part of the reaction when you see an increase in an oxidation state. So say that you start off with sulfur and it was 0 when it was reacting, but when you see in the product side it's a +2, then you see from a 0 to a +2 there's an increase. So hence there's an increasing number. And if you remember, when you increase a charge and it becomes more positively charged, it means that you lost electrons, which is why here increase in oxidation state correlates to loss of electrons. This also is synonymous to you seeing an increasing number of oxygen bonds. So here, I've actually had a few examples. So if you look at this, these are only oxidation examples, only oxidation. There is no reduction happening. So here you see an alcohol, and then it turns into an aldehyde. It got oxidized, but also look at what happens to the number of bonds to oxygen. It increased. So that is one of the indicators that if you see more bonds to oxygen, that you're probably dealing with an oxidation reaction right here. But we'll get to the examples in a second. Now, reduction is basically just the opposite of that. So if oxidation is the increase in oxidation state, then reduction would be the decrease in oxidation state and hence a gain in electrons. So say sulfur was, again, in the reactants was 0, but then in the products you see that it's a -2, it decreased, right? It went from a 0 to a -2, that's a decrease. So you're probably dealing with a reduction. And if you're gaining a negative charge, that means you're gaining electrons, because that's the only way you're getting more negative, if you gain electrons. Hence, a decrease in oxidation state means a gain in electrons, and usually this means an increase in the bonds to hydrogen, and you will see that example later down the road. So another common thing that students again get confused is, okay, oxidation reduction sounds simple, but then what is an oxidizing agent? So oxidizing and reducing agents are a little bit different. And basically what these agents are, they're also within the reaction, but what they do is a little bit different to what their name is. So an oxidizing agent helps another element another element get oxidized. So it helps another element in the reaction get oxidized. So that means this one itself gets reduced. I know that sounds confusing, but just, hear me out. So it's an element that accepts electrons, and remember, anything that accepts electrons, meaning it's gaining electrons, so itself gets reduced. So an oxidizing agent gets reduced itself so that it could help the other reactant in the reaction gain electrons, lose electrons. So an oxidizing agent helps another element or atom in the reaction get oxidized, while the agent itself gets reduced. And these are some examples of common oxidizing agents that you will see. They usually have a high affinity for electrons. High affinity meaning they usually like to take electrons very easily. And remember, anything that takes electrons is gaining electrons, so it's getting reduced. But if this one's getting reduced and it's helping the other one get oxidized. So this is a common oxidizing example where you will see probably in organic chemistry, alcohols will be oxidized to aldehydes and then further into carboxylic acids. And like I said, these are a few examples. So again, look at this one here. You have an aldehyde and it's turning into a carboxylic acid. Don't you see an increase in the number of bonds of oxygen? Here there were only 2 bonds to oxygen, but now there's 3. So there was an increase in the number of bonds of oxygen. Even in here, it's a very similar example. Alcohol to carboxylic, you increase in the number of oxygens. Same with this example. So the more you keep looking at examples of oxidation, you'll immediately get comfortable and realize, okay, I got it. Now, reducing agents. Remember, they're the opposite. So if oxidizing agents themselves get reduced, then reducing agents themselves get oxidized. So reducing agents, what they do is help the other element in the reaction get reduced. So they themselves, reducing agents, lose electrons. So hence, good reducing agents would be sodium, magnesium, aluminum, and zinc, and all of these have pretty low electronegativities because low electronegativity means easier for them to give up their electrons. And hence, remember, reducing agents themselves get oxidized so that they can help the other reactant in the reaction get reduced. And remember how I said reduction means a gain in the number of bonds to hydrogen? So we will see that here. Here again, we start with an aldehyde, only 1 bond to hydrogen. Now look at it here. We have 2 bonds to hydrogen. And if anything, we decreased in the bonds to oxygen. There were 2 here, but now there's only 1. This is an example of reduction. Same thing, 2 bonds to oxygen, now only 1 bond. There were no bonds to hydrogen, now there is an increase. Another example here. Another example here, you see that the number of bonds to oxygen are just decreasing in each example, right? And that's the basic difference between oxidation and reduction. This would require a few more examples, and there are 4 different types of oxidation reactions types, which are combination, displacement, combustion, and addition, which we will get into in another video.